Test tubes are now one of the standard methods used in gas analysis. But what exactly is a test tube? It's a sealed glass tube filled with a chemical reagent. When this reagent comes into contact with a specific gas, it reacts, causing a visible color change. My name is Stephanie Grünberg. I'm the product manager for tubes at Dräger, and in this video, I'll give you an overview of the various gas measurements that can be carried out using Dräger-Tubes. Dräger-Tubes can detect over 500 different substances and are used in a wide variety of applications, from occupational safety and environmental monitoring to emergencies. Their versatility makes them suitable for many industries and operational environments. Each Dräger tube contains a chemical reagent system. When exposed to specific gases or vapors, and in some cases also to aerosols or dust, the reagent reacts through a clear color change. Without the need for a power supply, tubes are particularly well suited to remote locations or environments where electricity is unavailable. Their long shelf life and low cost make them a reliable and economical solution for gas detection. To perform a measurement, a defined volume of air is drawn through the tube using a Dräger hand pump. Even small quantities of gas will trigger a visible color change in the reagent. Different layers inside the tube filter out interfering substances, allowing for specific detection of the target gas. A printed scale on the tube makes it particularly easy for the user to read and evaluate the results. This batch-specific scale serves as the calibration reference. Each tube is calibrated during production, making it ready to use without any further adjustment. Moreover, calibration certificates are available free of charge as a PDF for download, sharing, or viewing via Dräger Service Connect. For best results, we recommend evaluating the measurement result against a light background. The color change is especially easy to assess when compared side by side with an unused tube. With the Tubes app, users can digitally record, store, and share their measurement data. For more detailed information about the hazardous substance, simply search for it in our Dräger Voice database online. You'll find comprehensive data on chemical properties and occupational exposure limits. Dräger tubes are primarily used to measure airborne contaminants at concentrations relevant to workplace exposure limits. As regulatory limit values continue to decrease, more sensitive tube types are required. At Dräger, we continue to develop both classic tubes and microtubes to ensure this proven technology keeps pace with evolving standards. Our Dräger tube portfolio includes short-term tubes, tubes for detecting contaminants in compressed gases, and specialized sampling tubes and systems. Among the short-term tube options are the simultaneous test sets. Let's begin by looking at the short-term tubes. Short-term tubes typically require measurement times ranging from 10 seconds to 15 minutes. They offer a wide range of applications, including the measurement of airborne contaminants in relation to occupational exposure limits, testing storage tanks before entry, and detecting leaks in gas pipelines. As part of Dräger's tube-based measurement technology, simultaneous test sets were developed for specific application scenarios. Each set contains 5 Dräger tubes arranged in parallel in a rubber sleeve. These sets are typically used in situations such as fires or incidents involving the transport of hazardous materials. Compared to individual measurements, simultaneous test sets offer several advantages. Significantly reduced measurement time, the ability to detect 5 substances with parallel cross-referenced evaluation, and rapid assessment of the hazard situation. If a gas is detected at a concerning or critical concentration, a follow-up measurement using the appropriate Dräger tube is carried out to determine the precise value. However, when deciding on response measures, it's not only the current concentration that matters, but also how it develops over time. The specific conditions on site must also be taken into account. All final decisions rest with the local incident commander. In cases involving complex mixtures or chemically similar compounds such as methanol, ethanol, and propanol, direct reading Dräger tubes may be limited due to potential cross-sensitivities. In such situations, firstly take a sample using collection tubes, followed by laboratory analysis, for example using gas chromatography. Once the composition of the substances has been identified, further measurements can be carried out using short-term tubes. At Dräger, we offer not only a comprehensive portfolio of gas detection solutions, but also expert advice and a full range of support services, including free application-specific consulting for Dräger tube-based measurements, laboratory analysis of used sampling systems by the Dräger Analytical Services team, support on occupational hygiene and exposure-relevant topics, seminars and training from the Dräger Academy, our Dräger-tubes app, digital calibration certificates, and the Dräger Voice Hazardous Substance Database available online. All links and resources mentioned can be found in the video description below.